So first of all, number three. Number three, I did it the hard way. And then I was told by two people, well, first of all, Ethan said, I'll do it the easy way. And then Elena said, I'll see your easy way and raise you an even easier way. So the way I did it was I was thinking of the variable as being this angle because you have to cut this chunk out of this cone. And I went through all of this work and I got to this point, and I pulled an Ethan, and I used my computer to do the rest of this, and I got my maximum value. I also did it in general so that you could just type in your R here, so that whatever your value of R is, mine was 12 for the original circle. But if you have, so this would be the super cheater method. It's just whatever number you have in here for your big R, the circle, that's going to be your answer. But then this is Elena's method. So there's the volume of a cone, and then we have to substitute, get rid of one of the variables, and the variable we're going to get rid of is the R. So Ethan got rid of the H, but getting rid of the R is actually more efficient because you can take this there, that picture, and you have this nice, whoops, undo that erasure. You have this nice triangle here, which gives you this relationship using the Pythagorean theorem, or better yet, this relationship. And then I'm going to just replace the r squared with that. That way I don't have any radical. That was just a beautiful way of doing this. And then just do the derivative of this thing, set it equal to 0, solve for h, plug it in back. So I got h equals plus or minus radical 48, and I plugged that back in to this expression and got this, which gave me that. And I was super happy, as you can see, that it was exactly the same as what I got doing it the hard way when I was feeling not so happy.
Yeah, no, but my way's better.
That is a matter of opinion, apparently. Okay, let's move on to number 4, since that's another one that's a popular one. So give me a sec here. Let's find. So there's number 1. Just a minute. I'll make this big. Let me F11 to make it full screen. Beautiful, isn't it? So look at that. I even got it right there. Okay, so I had not expected this to be such a big problem when when I looked at it, but I think that this first one, that one was like the first box that you have to fill in is the hardest box to fill in. Once you get that first box, basically just follow the instructions through the rest of it. So let me do it for my number, but you could do it for your number, or if you're watching this from home, you can do it for your number. Just pause the video. But let me jot this down. I have a box. It is an open top box. Why do we like these open top boxes? I don't know. But here, let me draw this. Good enough. Okay, so here, I'll show you my open top box. There it is. It says that the base is square. And so x is going to be the side of and the front. So since the base is square. And it says that the volume is 442368. Why such a weird number? I don't know. It's like a random number. There it is, 442. That's the volume. So I'll write that down and I'll put it here. You can see. And we know the volume formula for a box. That's easy. Length times width times height. And so that's going to be x squared times h in my case is 442368. Now we need to figure out how much material we're using. And so just go ahead and add up all the pieces. So first off, this piece, that piece there is x times h is the area of that piece. So area is x times h for that piece. But you'll notice that we have 4 pieces that are basically x times h. So I made a little bit of room there. So this piece here is also x times h. That one and that one, they're all the same, x times h. So x times h, I'll just multiply that times 4. And then the bottom, that you can't see very well, but the bottom there is going to be x squared. And that's the amount of material I need for this particular box. So far, so good. This one wasn't too bad so far. Like I said, I saw this when I looked at this particular problem and picked it. I thought it was stepping you through all of this algebra. This is the hardest part, I feel, is the algebra. And then the rest of it, it's pretty straightforward. Okay, well, let's go ahead and finish up the algebra. It says in the instructions, it wants you to write the area in terms of just x. And so we need to do that. Basically, take this thing here, and we're going to replace the h with h is equal to 442,368 over x squared. So that means that my area formula will be 4x times 442,368 over x squared plus x squared. That is so ugly. I am not happy with this, but it's what we got. Let me type this in, then you can see exactly what I'm doing. So over here, we're going to type it right there. Come on, buddy. Where's that mouse? There it is. Okay. So I'm going to type 4x times, oh, why is it not typing? 4, why is my keyboard not working? Weird. Just a minute, something is awry. Can I type over here? Okay, I can type there. Why won't it let me type back here? Oh, there, it works now. Sorry, I don't know what happened. 4x times 442,368 all over x squared. I suppose I could have simplified that, couldn't I? Too late now. I'll simplify it before I do step 2. So there's my first answer. I might as well, let's just see if I got it right. Ooh, I got it right. So I suppose I should simplify this a little bit before I get to the derivative. So let's go back here. We're going to do our derivative. First of all, cancel this x. And then I guess I should multiply, shouldn't I? 442,368 times 4. Hold on a sec. 442,368 times 4 is equal to 1769472 x to the negative first plus x squared. So that's a. So now we'll do a prime, do the derivative. You know you're going to have to do the derivative. All this is saying is do the derivative, find the derivative. I guess I thought that it was pretty straightforward. I didn't realize that it would confuse so many people. 472 plus, x to the negative 2 plus 2x. So there's my derivative. Let's see if I get this one right. Okay, so we have negative 1769472 times, I'll just do it over x squared plus 2x. Are you able to check each one?
Yeah. Yeah, if you just leave the other ones blank.
Leave them blank? Okay, yeah, so you can check them as you go. So that might be, with a problem like this, it might be convenient. Okay, so the next one, it says calculate the derivative equal to 0. Okay, so, okay, that's easy enough. It even gives you a hint, as to how to do this. And then it wants to know, let's see, when x equals, okay, so let's see if I can do this. Okay, so I've got set this equal to 0, and I'll get negative, and I'm going to multiply both sides by x squared, so I'll get 1769472, 72 plus 2x cubed is equal to 0. So basically just this would be over x squared, and I'm going to multiply everything by x squared, which gives me this. So that means that 2x cubed is equal to 1769472. X cubed is equal to this, 9472 divided by 2. I'll do this on my calculator. I've got it, and then I'm just going to do the cube root. So cube root of that big number. Cube root. Oh, 96? Wow. It worked out. Maybe that's why they gave me such a crazy number to begin with. I got 96. Hopefully you got something nice and easy as well. 96. I suppose I don't have to click enter. I can just click this. Look, I got it right. Okay, now it says it wants you to compute the second derivative. Okay, so what is the second derivative? Let me go back to my original problem. Here it is. There's the first derivative right there. In fact, I'll just copy this so that I don't have to rewrite it. Copy, paste. There's the first derivative. So do the second derivative. Sure. So I'm going to have 2 times, hold on a minute, 2 times 1769472. So that gives me 3538944 x to the negative 3 plus 2. Does that look right? So there's my second derivative. Let me go ahead and type this in back here. 3538944 divided by x cubed plus 2. That look good? See if I'm right. So far so good. I'm still doing great. And then it says evaluate the second derivative at the x value. In other words, they want you to plug this number into here. So that 96 we're going to plug in there. And you know what? I don't want to do it. I refuse. Just a minute. Let me see if I can cheat. It's not cheating. It's just being smart about how you type this stuff. Wow, what just happened there? Oh well. Okay, so let's do it this way. Type in that big number divided by 96 cubed, and then we're going to add 2 to this. Will it let me do this? Oh, it's not a decimal. It won't. I actually have to do this on my calculator. I'm so lazy, I don't want to do it, but I will because I care about you. So divide this by 96 cubed, and then add 2. Oh, it's 6. Okay, so apparently they want you to actually type it in. There, that's it. That's all they want you to do. By the way, it says here that since your last answer is positive, it means that you're concave up. Concave up means that you have a minimum. You're at the bottom of a trough. You've got a minimum. So they just wanted you to step through this. And it says that your boss is happy, which means that you're happy too. So did I answer all the questions about number 4, all the confusion? And did I make you feel bad about how it was so simple? No, I'm just kidding. Don't feel bad because it is confusing when there's lots of words. We're not used to having to read in math classes. But that look good? Look good to you? Look good? Everyone? Everyone's happy? Good, because I've got lots of words on the quiz today. I'm curious to see how this goes. We'll see. And the reason why I'm curious is because this particular problem is an optimization problem that is unlike any of the optimization problems you did for homework. I know, you're thinking, why would you do this to me? Well, it's because the principle is still the same. You always draw a picture. I drew the picture for you, by the way. Write a formula, get it to be a single variable, do the derivative, set the derivative equal to 0, solve, and I step you through it just in case. To me, the hardest part is coming up with a formula. And so I've got hopefully enough instruction on the quiz to help you with that. But you should be able to do this without all the words. So if you prefer, here, I'll show you what you can do in just a minute. If you don't like the words, there's a way to ignore them. Here you are. Okay, so let's say that you don't like all the words. Here's what you do. You take your quiz, fold it like this. Just a sec. There. Fold it like that so that you don't have to see all of those A, B, C, D, E, F, and G. And just do the problem without following my guide. You know, I thought that the guide, it would guide you through it, but you know, do your best. I've got it up here for whoever's watching the video. Ooh, it's really big. Make it small. So, there, and if you are watching the video, you should pause so you can read and then move on. no mess. Here, you could just have the whole bag.
My brother ate it like candy when I was little.
Nice. Looks like some of you are done. Some of you are meditating. If you can't do a particular part, you could always skip and just fill in the answer at the bottom. If you're not sure what to do with like F or something, I don't know. Do your best. I'll see what we have. See if I got it right. You just crossed out the correct answer.
That was correct.
I don't know.
But I just got angry because it wasn't working out, so I crossed it all out.
Put something down. You got something down?
I don't think it's right at all, but I was a little lost. But you know what? If I see somebody else do it, I can help you with that.
Coming down the home stretch here. Very nice. This was really good, just I love it. You got something? You got some numbers. Fantastic. Okay. You're all done? You're all done? Oh. something. All right. Well, this
It's an
is
answer.
an experiment that I don't know if it was a fail or not, but I do have a variety of answers, which at first surprised me, but then I realized it all comes down to the top, the very first instruction. That if you followed my instruction, well, it depends on how you interpret it. Yeah, you know what? I just realized. Yeah, it could be interpreted multiple ways. So I'll show you how I interpreted it, and then we'll see how you did. So here's mine. Where is that thing? There it is. So here's the way I interpreted it. If you put an X like here, 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 that's fine. It's just that your X is different from my X. It still should work out either way. However you label this, I was just trying to help you, and it may have been better if I'd left off all of my instructions and just let you go to it. But there it is. Um, now, let me just do this for the people who did it the other way. If you put an X here and here and here, this is just so you know, there's two ways to go about this. My area, the total area is just X times Y. So the area of the whole thing. So I guess that you could have done the same if you had the little x instead of, it probably would work out the same. But anyway, let's move on. The length of fencing needed, I think I counted this correctly. I've got 4 y's, that's 4 up downs. And then I've got 2 of the acrosses. This will be different if you used the green x's. Yours would be 4y plus 6x. Still, you should end up with this or similar or related answer. But anyway, I knew that I had 1,024 feet of fencing, and so this is where I am. And I won't show you, I won't mention the little x's again, but if you did it with the little x's, you're probably correct. It's just your answer will look a little bit different from mine. Anyway, here's this. I'm going to plug this into, substitute, that's it. I solved for y, stuck it in here for x. So notice that my area is now x times this nasty thing. And then I simplified that down here. And then I just did the calculus. Take the derivative, set the derivative equal to 0. I ended up with x equals 256. I want to find the actual area. So 256, I basically plugged 256 into my area formula up here. Here's the formula. I used that formula because I thought that would be easier. Yeah, ignore this. That's just me thinking. But I got 32,768, which happens to be 2 to the 15th. But so my final answer was 32,768 when x is equal to 256 and y is equal to 128. I did double check both ways. I did it using the second derivative test. Second derivative just happens to be -1 for everything, so relative max for sure. Or you can use the first derivative test, pick a point like 1 over here or 0, and over here you could pick 1,000,000 for test points. Get the slope. Should increase then decrease. If you had the smaller, let's see, if you had the smaller x, then your x's would be 256 over 3. And possibly, depending on how you interpreted this, the area might be this divided by 3. So if you got a weird decimal, you're probably right as well. So I'll be kind and gentle as I grade these and give points liberally for almost anything. But I just wanted you to have an experience of doing optimization problem, because this is what happens, especially when you get to Calculus 2 and multivariable calculus. If you do those courses, I know some of you are like, I'm never going to do that. But you bump into a optimization problem that's completely different from anything. No, it's not a box. It's not a cone. It's not we're doing Max-Min problems for business today. It's none of that. It's something completely different, but it has the same sort of form. You basically, when you have anything that's looking for the largest or the smallest, here it was largest, You just have to somehow get yourself a formula that just has a single variable and then do the whole derivative thing and go from there. Okay, so let me switch. I should have had this. I had most of it set up, but I forgot to do this one thing. Not that. Welcome to Ohio. Discard. Okay, let's go back here. That was for a different class.
Is that like a variation on the seven bridges problem?
It is amazing. Okay, here we are. Let's see. Is this the one that has my stuff? No. See, I ended up opening way too many. Let me figure out which one I need to do here. Just a minute. I have to get the correct one. I opened a whole bunch of things this morning, so I have to find the right one. Here it is. Optimization 2. Let's just save. Maybe I'll just make a little note there. Save. Okay, let's see. Will it? Come on. Why is it not updating? Okay, this is optimization 2. This one. This is the one. Okay, yeah, this one's important because I have here the upcoming classes. Ignore that last thing there. That was me typing. That was when I was trying to figure out why it was not typing earlier. There, I'll get rid of it. So, L'Hopital, that's Monday. So today we're going to be doing a little bit more optimization. We'll do L'Hopital, and it's not a difficult thing. Newton we're going to deal with on Tuesday. We'll do antidrifters Wednesday. Now here's the thing though, is there's all this stuff going on in the next 2 weeks, and it's cluttering the calendar and messing me up and messing you up too. So the things that are happening are we have Good Friday, Easter Monday. Both of those days are off. Then we get a day that we get to be in class. So the third exam is actually going to be Wednesday the 3rd. So I'd said it was going to be this week. I think I had originally said it was going to be Friday, but I have problems with Friday. You can see online videos we're going to do on Friday. So I'll give you instructions for Friday before I guess 2 weeks from now. That's 2 weeks from now. So the thing that I have Friday is that my daughter is getting her PhD in UNC Chapel Hill, and she said I have to go. So I guess I got to go see her get her thing. So that's the end. So that's why I'm not going to be here that Friday, the 5th. But I'll give you instructions, and I'm letting you know now so that you can plan not to drive if you have a long distance to drive to get here that particular Friday. There also is the Monday after this. I'll be back, don't worry. But that's the eclipse day, but that won't affect our class. So my afternoon class, I'm going to let them go a little early so that you can go find some good spot to go observe, unless it's cloudy, like it is most days in Ohio, in which case we'll just watch the sky get dark and then get light again. Well, that was exciting. We'll see. Yeah, by the way, this eclipse thing, it's a rarity. This is the first time in my life that I've been somewhere where there's going to be a total eclipse. So I'm very excited. 55 years. Never have I been in an actual location. So it's a rarity. I know that it may seem like we had an annular eclipse maybe 5 or 6 years ago, so it's like old hat for you guys. But
We have one in the fall.
There's one in the fall. Where?
There was one.
Oh, there was one in the fall.
Mm-hmm.
An annular?
It was a partial eclipse.
Partial, yeah, it's partial eclipse. So whatever. Not as exciting. No, this is total eclipse. Yeah, there's plenty of you get the moon eclipse, the lunar eclipse. Those happen pretty frequently. But getting a total eclipse of the sun, very exciting. So drink it in and enjoy the creation. Okay, let's move on. Let's do this. So this is all we're doing today. Basically, you know what to do. I'm just going to try to help you piece it together. So we're just putting together this profit, revenue, cost, and demand into problems that involve optimization. You can imagine the sort of optimizations you're going to want to do. You want to minimize cost. You want to maximize revenue, maximize profit. Those are the questions that you're going to see on your homework for Monday, is things like that. If you understand this screen, then you're all set. You could probably just leave right now. But we might as well do an example or two. This we had earlier this semester, so this is a repeat. But just to remind you, P is for profit, R is revenue. This is the money we take in, but it's not the profit. This is the actual cash that we take in um, before we pay our costs. C is cost. How much do we have to actually pay our workers, pay for the materials, pay for the energy that we're using to keep the lights on, those sorts of things. Demand function, X is equal to F of P, where P is the price. So this is this idea that if you increase prices, you decrease the demand. Our institution, MPNU, is extremely sensitive to this, and so every year we say, how much can we increase the tuition without, discouraging students from coming, and that sort of thing. I'm not the one making that decision, so don't blame me. It's the board of trustees, and I think that they just met here last week or so, and so you can blame them if you ever see them. But anyway, if we were to increase our tuition considerably, we would likely have a decrease in the enrollment. So the X here is the number of students for us. The P is the price, the tuition. And of course, the cost, they have to pay my salary, well, unless there's an emergency and they just fire me. So we have salaries and stuff here. Revenue is the amount of money brought in, but we hope to break even. MVNU does not make a profit. We are nonprofit. There is no profit. Trust me. I've seen the books. I've seen the thing. But anyway, getting back to this, let's take a look at an example of this. And this one has way too many words again, but we're going to do this. We're going to be okay. Whoops. I pressed the wrong button. There, that's the right button. Let me switch over to Notability so I can write on this. Go down here where I have some room. Give me a sec. I'm just going to put this thing in here. This one. There it is. Okay, so here is the example that we're going to be looking at. And I'm even going to do this because I can. Convert to ink. I don't know why when you convert it to ink, it makes it look ugly. You'd think that it could figure it out. But whatever, it still isn't too bad. I just wanted to stretch out this stuff at the bottom here. Let's see if I can do that. Let's do this. There. Okay, so let's go ahead and answer these questions. This is similar to one of the questions on your homework, and so I thought this would be a good one to do here. So we have a cost function, we have a demand function up here. So it's in terms of the price, not in terms of X, but still. The profit, we want to know the profit when 50 widgets are sold, so we need to come up with the profit function. The profit is going to be the revenue minus the cost. Whoops. No, not equals, minus the cost. Well, we need to know the revenue. The revenue is equal to X times P, the number of units sold times the price. So, and I'm using a boring thing here, widgets, but I was thrilled, overjoyed, in fact, when I looked at the homework options that they actually had things that you might care about, and they had pictures. So if you've looked at the homework for Monday already, you see there's a picture of a bicycle and there's a picture of a dog. And so I thought that some of you would get happy about the bicycle, maybe just me. Some of you would get happy about the dog. And probably the Venn diagram has a very small overlap because bicyclists are the sworn enemies of dogs in general. Anyway, at least, or maybe it's the other way around. Dogs. Whenever I bike by, the dogs always want to chase me. They're looking to get a chunk of my flesh. I think they see my calf and they think, that looks tasty. But anyway, getting back here, the profit in this case is going to be the revenue, which is X times 9,000 minus X, minus the cost, which is 10,000 plus 100X plus X squared. So if we want to know the profit when you're selling 50 widgets, you just have to plug 50 into that expression. Well, I don't want to have to do that. Maybe I'll simplify it before I do it. So P of X is 9,000X minus X squared minus 10,000. Give me a sec here. This will help us out in a minute. Don't forget to spread the negativity there. And then let's clean things up. Let's see, if I have 9,000x minus 100x, that gives me 8,900x minus 10,000 minus 2x squared. Sorry, there's two of them. Do you see the two? I do. 2x squared. You can do it. I still haven't even answered the question. What is the profit when 50 widgets are sold? Well, do it. P of 50 is equal to, pull out the calculator. There it is. How much time do we have? We have 10 minutes. We can do this. Clear, clear, clear. Let's see. 8,900 times 50 minus 10,000 minus 2 times 50 squared. And that gives me a profit of 430,000. Wow, it's a lot of profit. Okay, what about the average profit per widget as a function of X? Okay, so think about what this means. So like I said, I just copied this directly from the homework so that we would have something that's similar to the homework. Let me just do this. Oh no, that was no good. I need to grab the whole thing. Hold on a sec. Okay, that's better. So average profit per widget, that would be the total profit divided by the number of widgets. That's it. That's the average profit. So average profit is this. So go ahead and do this in terms of the profit. I'm going to just use that expression right there. 8,900x minus 10,000 minus 2x squared all over x. I could probably simplify this, but I'll bet you Lumen wouldn't care if you didn't simplify it. I'm going to simplify it though, like this. So that's the average profit. Yeah, most of this I wasn't as excited about as apparently Lumen is, but I will just follow. I'll play the game. The next one is, what is the rate the profit is changing when exactly 50 widgets are sold? Well, look at this. It's the rate that profit is changing. So the profit is changing at this rate. We need the profit prime, P prime. I think the confusing thing about this is that they asked you for the average profit and then suddenly they go back to the regular profit. So we're going way back up there. At least it's not one of the minor profits. But let's do this. We do the derivative here, 8,900 minus 4x. I think that's going to do it, isn't it? So that's the rate at which the profit is changing. And then we just want to do P prime of 50. Sorry, 50 is 8,900 minus apparently 200. 4 times 50 is 200. And that'll be 8,700. So that's $8,700 per widget is the rate at which profit is changing. In other words, every time you make another widget, you get $8,700 more profit. So you might as well start pumping out the widgets at this point because you have a pretty steep curve there. The marginal profit is what that's also referred to. How much more profit do you get for each widget that you make? Okay, now we'll deal with the maximum. Finally, we get to the maximum. Well, we have P prime right there, so we might as well do P prime equals 0. So that means 4x is equal to 8,900. Divide both sides by 4. Here I'm just going to be lazy. I'm sure I could do this in my head, but 2225. And that's the answer to the number of widgets that must be sold to maximize the profit. But the maximum profit will be P of 2225. And here I'm going to have to actually do this 8,900x minus 10,000 minus 2x squared. Yep, that's the profit. So that's the profit. Let's do P of 2225 now. So I'm just going to plug 2225 into that formula. 900 minus 10,000 minus 2 times 2225 squared. And I got 9,891,250. Look at this. We are millionaires now. $9 million for this one. Very nice. Almost $10 million. That is amazing. Okay, so let's take a peek here at the homework. Where are we? Do we go forward? No, I don't know where we're going. This one. No, not L'Hopital. Let's go back one. Applied number 2. This is it. Here we go. We'll do L'Hopital on Monday. So look, so we have concentration of a drug. We didn't go over one like this, but I think you can figure this out. We want to know, speaking of drugs, this might be the concentration of ibuprofen in your blood after taking 12 pills. But whatever the situation is, we want to know when is the concentration of maximum, because when you take those pills, they don't go, it takes a while to get absorbed, and then it hits a maximum, but then starts to decline as you metabolize the stuff. So how long? Just do the derivative, set it equal to 0. You can do this. Okay, this is the one that has lots of questions, but it's the same questions that we just did. This one is custom-built cabinets in mobile homes or motorhomes. So you can do that. I promised you some pictures. Look at that beautiful folding bike there. So here you have the cost function and the demand function, and you have to find the maximum profit. And then you have this one where you're selling dog leashes. And once again, to make you happy, you have a picture of a dog there. So if you need to, if it helps you, you can either look at that picture or this picture to give yourself inspiration. All right, I'm going to stop this, and I'll put that list. Where is the list? Just in case you are need it. There's the list of upcoming events. Oh, not there yet. There it is. Upcoming events. Joy. So